Ugh. What's this? What made that apple fall down? Gravity. Yes, you're right. But what exactly is that? Well, Sir Isaac Newton postulated that gravity is a force of attraction between two masses, in this case, the apple and the Earth. But if we look at Mercury, Newton's laws can't fully predict its orbit. The rotation of its orbital path proceeds faster than Newton's laws predict. What could possibly be happening? Let's combine space and time into a 4D model. Could gravity from objects be bending space-time? Let's check in with Sir Isaac.
What could possibly warp space and time, am I right?
Whoa, move aside, dude.
Hey!
Actually, according to Einstein, the fabric of space-time can be warped. Let's imagine this space-time, this towel right here. If we place a very massive object, say a rock, into the center, you can see that space-time is curved. And this affects how other objects move as well. This ball, which is smaller than this rock, will roll and roll closer to the center of the universe. And now space-time tells matter how to move, but matter tells space-time how to curve. Now, when a big enough star collapses, it can form a black hole, an entity that bends space-time so much that even light can't escape. But if there's no light and we can't see black holes, how do we know they exist? When two black holes orbit one another, they slowly lose energy over time and produce gravitational waves. You can think of them like ripples in the fabric of space-time, like these. How can we detect these gravitational waves from black holes? Enter LIGO, a gravitational wave detector, in the swamps of Louisiana or the deserts of Washington. So LIGO has these two really long arms and a laser in the back, which sends a laser this way. Part of it is deflected by a mirror over here in that arm, while the other part of the laser goes into the other arm. There's two mirrors in the back of these arms, so that when the light waves are reflected back from these arms, they will destructively interfere. In other words, no light will be detected. But if light is detected, then that means, the arms have been squeezed and stretched, which is a sign of gravitational waves. Well, the one in Louisiana and the one in Washington both show the exact same patterns of squeezing and stretching. Then we can confirm that these were due to gravitational waves. And if these gravitational waves were characteristic of black holes, we can go back and calculate how far these black holes are and how massive they are.